So hi, we are from Group 1. I'm Muhammad Iskandar. I'm going to talk about introduction of amplitude modulation. So what is amplitude modulation? Or we call as AM for the short form one. AM is basically a technique used in electronic communications to encode information onto a carrier signal by varying the amplitude of the carrier wave. This modulation technique plays a pivotal role in a range of communication systems, particularly in the radio broadcasting industry. It's considered one of the simplest modulation methods and was historically the first method used for audio transmission in radio communication. So for the basic concept part, is the fundamental idea behind amplitude modulation is to combine a high frequency carrier wave with a lower frequency message signal, typically an audio or data signal, by varying the amplitude of the carrier wave in direct proportion to the amplitude of the message signal. The resulting waveform carries the information needed for communication. As you can see, we already given the equation for amplitude modulation. Amplitude modulation consists three parts that we need to understand about how the amplitude modulation works. So for the first one is carrier frequency. This is the original frequency of the unmodulated carrier wave and is central to the communication. Next, lower sideband or LSB. This component contains frequencies that are lower than the carrier frequency, generated by subtracting the message signal frequency from the carrier. And the last but not least is upper sideband, or we call as USB. This component contains frequencies that are higher than the carrier frequency, which is generated by adding the message signals frequency to the carrier. So what are the advantages of amplitude modulation in communication system? So amplitude modulation provides simple demodulation, its simplicity and low cost, and it can cover a wide coverage, and last but not least, its compatibility with existing infrastructure.
So today we'll explore amplitude modulation or AM, a fundamental technique in electronic communication. Amplitude modulation is primarily used to transmit information such as audio or data via a radio carrier wave. Let's break it down. The carrier wave, this is a high frequency sinusoidal wave. Think of it as the base signal that carries the information over a long distance. The message signal, this is a low frequency signal that contains the actual information like music, speech or data that we need to transmit. So the modulated wave, we combine the message signal with the carrier's wave, we get the modulated wave. In AM, the amplitude of the carrier wave is very proportional to the message signal, while the frequency of the carrier wave remains constant. So how does this work? So imagine this, a carrier wave, think of a smooth blank wave is like a train ready to carry something. So the message signal, this is your music, voice or any sound, is what you want to send. So the modulated wave, now imagine the train carrying your message. The train changes its size or amplitude to match the highs and lows of your message. So how does this work? Well, we'll start off with the plain wave called the carrier wave. Change the height or amplitude of the wave to follow the pattern of your message, whether it's music, speech or another sound. So this modulated wave is sent out carrying your message to receiver like a radio. So why use AM? Amplitude modulation was one of the first ways to broadcast audio over radio wave. It's still used in AM radio station, airplane communication and even old school walkie-talkies. So the next time you tune into an AM radio station, remember, you're listening to waves that have been shaped to carry message across great distance. So what is quadrature amplitude modulation? It is used to carry waves that are 90 degrees out of phase, hence quadrature. These carriers are modulated both in amplitude and phase to encode information. Here are the possible variations that apply to QAM, that is quadrature amplitude modulation. So amplitude modulation, both carriers have their amplitude modulated independently. The amplitude level corresponds to the information being transmitted. So next is phase modulation. The phase of the carrier is adjusted, which is additional states for encoding more information. So the combining of amplitude and phase modulation, this is start of the defining characteristic of QAM. Information is encoded in both the amplitude and phase of the carrier simultaneously, making it highly efficient. So how QAM works? So the two carriers typically called in the phase 1 and quadrature Q components are combined by varying both the amplitude and phase of the I and Q signals. The QAM achieve higher data rates. So the application of using this technology is QAM is widely used in digital TVs, modems, cellular networks such as 4G and 5G.
Okay, so what is angular modulation? Angular modulation is process of varying the angle, phase or frequency of a high frequency carrier wave to encode the massive signal. Unlike amplitude modulation, where the carrier wave amplitude change, angle modulation keeps the amplitude constant, which improves noise immunity. Okay, so they have two types of angle modulation. First, frequency modulation. The frequency of carrier wave varies with the amplitude of modulating signal. Higher amplitude in the input signal leads to a higher deviation in the frequency. Second, phase modulation. The phase of carrier wave varies with the amplitude of the modulating signal. A change in the amplitude of the input signal causes a proportion change in the carrier phase. Okay, next, for the characteristic of angle modulation. First, constant amplitude. The amplitude of the carrier wave remains unchanged, which reduces noise and distortion. Second, wide bandwidth. Angle modulation techniques typically require a wider bandwidth than AM, especially for FM. Third, noise resistant. Angle modulation offers better resistance to noise, especially random noise that primarily affect amplitude. Okay, so for advantage, first, improve signal quality. Second, resilience to noise. And third, constant power transmission. So for disadvantage, higher bandwidth requirements, complex receiver design and line of sight requirement. Application for frequency modulation: FM radio, sound transmission in analog TV, two-way radio such as walkie-talkies and radar and telemetry system. For application for phase modulation, used as a basis for digital modulation scheme like phase shift keying (PSK), satellite communication, and mobile and wireless communication system. Okay, so this is comparison between angle modulation and amplitude modulation. Angle modulation has constant amplitude and amplitude modulation varies with signal amplitude. Angle modulation has higher noise immunity than amplitude modulation. Angle modulation has wider bandwidth than amplitude modulation. Angle modulation has more efficient power than amplitude modulation. And last, angle modulation has more complex than amplitude modulation.
Next, let's move on to radio digital modulation. Radio digital modulation is a process of encoding digital signal onto carrier wave for transmission through free space. For example, information such as data or voice transmitted without the need of cables or any physical medium. This modulation involves shift keying technique, where the carrier wave properties are varied between discrete value to represent binary state 0 and 1. First, let's see together what is amplitude shift keying, ASK. ASK is change of amplitude of the carrier signal by digital signal. As shown in the figure, when binary 0, the amplitude is low. When binary 1, the amplitude is high. For frequency shift keying, FSK, it can be achieved by two generations of ASK waveform. When the binary data is 1, the frequency is high. As you can see, the gap is closer, which means more cycle per second is generated, while the binary 0 produces low frequency. Next, phase shift keying PSK. PSK is setting the carrier signal to 0 or 180 degrees depending on the digital signal. For binary 0 to 1 or 1 to 0, phase is shifted by 180 degrees, while from 1 to 1 or 0 to 0, the phase is remain unchanged. Now let's see the applications of radio digital modulation. For the first one is military communications. Radio digital modulation plays a crucial role in ensuring secure and encrypted communications for military operation. It supports long-range transmission even in challenging environments. Next, we have mobile communications. Radio digital modulation is the backbone of technologies such as 4G and 5G. It allows us to experience high-speed internet, clear voice calls, and reliable video streaming. For the third one is radar system. Digital modulation is vital for radar systems which are used in air traffic control, weather monitoring, and defense applications. It ensures accurate detection and tracking objects, contributing to safety and efficiency in this field. So from all of the modulations, we can conclude that they play a crucial role in different parts of communications depending on the application, such as amplitude modulation provide a straightforward implementation and make it suitable for a long distance interaction. Angle modulation aiding in making a high quality signals due to a superior noise immunity. Next, radio digital modulation are essential for communication nowadays due to advancements of wireless communication system. That's all from us. Thank you.